Again, welcome to DSRT 734 class. And in this lecture, we're going to study about the measure of variation, that is finding the range, standard deviation, and variance. So our main objective today is to study about how to find the range of a data set, also how to find the variance, standard deviation of a population, and also of a sample. Also using the empirical rule and Chebychev's theorem to interpret the standard deviation. We're going to approximate the sample standard deviation for grouped data. So first we start with the range. The range normally is the difference between the maximum and the minimal data entries in the data set. So what we mean is that if I have a data set, and the values in the data set, I'll find the difference of the lowest value and the highest value, and that will give me the range. The measure of a variation tells us how individual data varies from each other, how they vary. So finding the range again is the difference of the minimum and maximum value. And in finding the range, since we are using arithmetic operation, finding the difference, the data must be quantitative. So this is the formula. The range is the mass data entry minus the minimal data entry. So we have an example here. They say we should find the range. Here, corporation hired 10 graduates, and the starting salary for each graduate are shown. Find the range of the starting salary. So here, the values are in thousands. So we have 41,000, 38,000, 39,000, etc. Now, to find the range of these 10 graduates, we just have to look for the maximum and also the minimum salary, then we find the difference. So here we can see that the maximum value or salary is 47,000. The minimum is 37,000. So the difference of 47 minus 37, which will give me 10,000. Again, the values are in thousands, so 10 means 10,000. So finding the range again is the difference of the minimum and the maximum value in the data set. Now, next we're going to, before we find the variance and standard deviation, we start with the deviation first. A deviation is the difference between a value and the mean. So here we say the difference between the data entry, a single value in the data set, and also the mean of the whole data set. To find the mean of a data set, we have to add all the values and divide by the number of values. Now, to find the deviation, we subtract each individual value with the mean. So we subtract the mean from each individual value, and that will give us the deviation. So the formula is X means one individual value, one value minus the mean, and that will give us the deviation. For sample, the same thing, individual value X minus the sample mean. Mean is the population mean, and then the sample mean. So example is given here, the same employee with their 10 salaries, 10 graduates, their starting salary. And the question says we should find the deviation of the starting salaries. So here, deviation of the starting salary means we are going to find 10, if the salaries are 10, then we're going to find the 10 deviation value. First, we find the mean of the whole data set. Then we subtract the mean from each value, and that's the deviation for each value. So we're going to get 10 deviations. So the first thing we did here is to find the mean. The total value is 450, and the number of values is 10. So we divide 415 by 10, and that gives us 41.5. Then we are going to find the deviation. So you can see here, we subtract the mean from each value. Difference of 41, 41.5, difference of 38 and 41. So 41.5 we subtract from each value, and that will give us the deviation. Now, the total deviation always will give us 0. The reason why, because the mean of the value is like the center of the value. So when you subtract the mean of the value of the data set from each value, and you add all, you will get 0. because since the mean is the center of the value, some of the values are less than the mean and some of the values are greater. So they will cancel each other and get 0. This is the reason why when we are looking for variance or standard deviation, we also find the mean from each value, but we square so that we will get rid of the negative value. So we square before we had everything. So total deviation always is 0. Now, how do we find the variance? It's almost the same as the deviation, but this time we find individual value minus the mean all square before we add all together. So we don't get 0. Then after that, we divide. If it's population, we divide by the population size. If it's sample, we divide by the sample size minus 1. So to find the population variance is the deviation square sum of all the deviation square divided by the population size. Then the square root of the variance will give us the standard deviation. Again, square root of the variance. Now first, to find the population variance and standard deviation, this is step by step in words. First, you find the mean of the population data set. Same as a sample, so you find the mean of the sample data set, which will be sum all the values divided by the number of values. Then next, you find the deviation of each entry. Do not sum it, we just find the deviation of each entry. Deviation means the difference of the value or each entry minus the mean. Then later, we square it. We square each deviation. After we square finish, then we sum it together. So we call this sum of square SS because we square it before we sum. Now, we saw the total deviation. If you don't square it and you sum all, you get 0. So that's the main reason why. And the reason why we get 0, the mean, some of the values will be greater than the mean, some of the value will be lesser than, because the mean is the central. So they will cancel to balance. So after we get the sum of squares, which is we sum all the square deviation, then we are going to divide again. In population, we divide by the population size. If it's sample, we divide by the sample size minus 1. So after we get the variance, then we find the square root of the variance, and that will give us the standard deviation. So this is an example given to us again. We already know the mean. So the mean, we had all the value, we divide by 10, the mean was 41.5. Now we are going to subtract the mean from each value. We subtract the mean from each value. The mean is 41.5, each value we subtract. Then we square it first. So negative 0.5 become 0.25. Negative 3.5 square become 12.25. So we square everything. Now when we square finish, we sum all. So this will be a sum of square 88.5. Then we divide 88.5 by 10, which is the number of values we have. And that will be the next step. Divide by 10, the population size. So that will give us the variance, 8.9. Then we find the square root of the variance, and that will give us the standard deviation. So in the sample size, the steps are the same. The difference is we divide by n minus 1. So we have to subtract 1 from the sample size. But again, the steps are the same. Then we find the square root of the variance, will give us the standard deviation. So this is for the sample variance and standard deviation. First, we find the sample mean, same step as population. Then we find a deviation, which is the same step. Subtract the sample mean from each value. Then square it. Then after we square it, we sum it together. Then when we sum it, we divide by the sample size minus 1. This is only difference between population and sample. Population we divide by the population size. Sample we divide by sample size minus 1. Then we square it, and that will give us the standard deviation. So let's see the example here again. Here we are zooming now. This is a sample, not a population. So we find the mean, we had all the value, we get 41.5 the same. Now we find the deviation of each value. Then we square all the deviation before we sum it. Then the difference is we divide by, instead of dividing by 10, we divide by 10 minus 1. That's sample variance. The answer we get, we find the square root, and that will give us the standard deviation. So how do we interpret the standard deviation? As we said earlier, standard deviation normally tells us how the data are deviate, each value deviate from the mean, or how the data varies. So standard deviation is a measure of a typical amount of an entry that deviate from the mean. So the more the entries are spread out, the greater will be the standard deviation. So if I have a value, let's say 1, 2, 3, 4, and I have another value, 2, 4, 6, 8. They are all 4 values, and they are all increasing. But since 1, 2, 3 is increased by only 1, 2, 4, 6, 8 is increasing by 2, the standard deviation of 2, 4, 6, 8 will be greater than 1, 2, 3, 4. So it's how the data is spread. When the data is spread out higher or bigger, the standard deviation value becomes bigger also. So we're going to interpret standard deviation using the empirical rule 68, 95, 99.7. We're going to use this rule in the normal distributions also. So for example, here we say for data with a symmetric bell shape, which a symmetric bell shape means we have a normal distribution. So that's why I said this idea will be used in when we cover probability and normal distribution. So here the only thing we should know that when we have the data set that is symmetric or is a bell shape, we always say that 68% of the values will lie between 1 standard deviation, 95% will lie between 2 standard deviation plus or minus the mean. Then 99.7 will be 3 standard deviation. So if I want to see the value from beginning to the end, and if I know the mean of the value, I will have mean plus or minus 3 standard deviation. That will be 99.7%. And we find the starting and the ending. So we say about 68% of the data lie within 1 standard deviation of the mean, 95% of the data lie within 2 standard deviations of the mean, and 99.7% of the data lie within 3 standard deviations of the mean. And this is how it looks. So we have the middle here, which is our S bar. So we assume this is sample. The mean always in the middle for symmetric. Then S plus 1, S minus 1, which is the S bar, the mean plus minus the standard deviation, 1 standard deviation. 68% of the distribution will be here, the blue area here. Then S negative, S bar minus 2S, S bar plus 2S, 95% of the data will be between here, before green and before green here. Actually, that's what we are 34, and that's 95. And then the rest is 99.7, will be on 3 standard deviation. So the 68% is on 1 standard deviation, 2 standard deviation is 95%, and 3 standard deviation is 99.7. So here we say we have a survey conducted by the National Center for Health Statistics. The sample mean height of women in the United States ages between 20 to 29 was 64 inches, with a sample standard deviation of 2.71 inches. Here they say we should estimate the percent of women whose heights are between 64 inches and 69.42 inches. So here we have to know the standard deviation. It's already given to us. Standard deviation is 2.71. So we know the mean is 64. So based on the standard deviation value, 2.71, so we say 64 plus 2.71, 64 minus 2.71. That will give us 68%. Now for 95% distribution, it will be the X bar plus two standard deviations. So standard deviation is 2.71. The S bar is 64, so it will be 64 plus 2 times 2.7. So that will give us a 69.42. Three standard deviation will be our 99.7%. Also, we have what we call the Chebychev's theorem. Here we say the portion of any data set lying within the K standard deviation, K must be greater than 1 of the mean, is at least 1 minus 1 over K squared. Only if K is greater than 1 within 2, 3, 4 standard deviations, we can say that the mean will be 1 minus 1 over K squared. K is the number of standard deviations. So example here said, if K equal to 2, in any data set, at least 1 minus 1 over 2 squared, which will give me 3/4 or 75% of the data will always lie within 2 standard deviation of the mean. We say 2 standard deviation because K is 2. 3 standard deviation means K is 3. So K is 3, we get 1 minus 1 over 3 squared, and that will give us 88.9%. As the K increases again, we can see the distribution interval also increases. So this is an example. We have age distribution for Florida that's shown below. The ages is the horizontal line 5, 15, 25 up to 85. Here they say we should apply Chebychev's theorem to the data using K equal to 2. What can you conclude? First of all, luckily we have the mean. We also have the standard deviation. So for 1, we get 39. For 1 standard deviation distribution, which is 65%, we get 39 plus 1 plus and minus 24.8. Again, to be 39.2 plus and minus 24.8. So the solution will give us the beginning and the end of 68%. So here we are looking for 2 standard deviation. So it will be mean plus or minus 2 standard deviation. Mean is 39.2 minus 2, standard deviation is 24.8. So this will give us minus, so that's the smallest part. Then we do to the positive, mean plus 2 standard deviation, that gives us 88.8. So we can conclude that 95% of the data will fall between negative 10.4 to 88.8. So here we say at least 75% of the population of Florida is between 0 to 88.8 years. Thus, this is standard deviation for group data. This concept is the same as when we find the central tendency or the mean for group data. The group data means how many times the data appears. So the same thing if I'm doing deviation here. If 2 appears 10 times, I don't want to say 2 minus the mean all square plus 2 minus the mean again all square plus 2 10 times. No, just take only 2 minus the mean all square. Then multiply by 10 if the 2 appear 10 times. Or multiply by any number of times the x appears. And that's what we call the group data. Then we still divide by n minus 1. This is a sample. So here we say when a frequency distribution has classes, we should estimate the sample mean and also sample deviation by using the midpoint of each class. So this is example given. You collect a random sample of number of children per household in a region. Find the sample mean and the sample standard deviation of the data set. So we have this data. Sample mean means again, we are going to have, but now I have so many, I don't want to say 1 plus 1 plus 1 plus 1 plus 1. I mean, we have more than 10 ones, and you don't want that's too long. So we can arrange this value in an increasing order, sorting. Then if 10 appear, sorry, if 1 appear 10 times, then we just say 1 times 10 instead of saying 1 plus 1 plus 1 10 times. And that's what we did here. So we know 0 appear 10 times, 1 appear 19 times, 2 appear 7 times, 3 appear 7 times, 4, So the total value here is 50 because the frequency also is 50. So we have 50 set of values. So if we know this and they say we should find the standard deviation, the first thing we have to look for is the mean. After we get the mean using the frequency also, the total frequency is 50. So we may say 0 times 10 plus 1 times 19 plus 2 times 7 plus, and then we keep going. 2 times 7 is like writing 2 plus 7, 2 plus 2 plus 2 plus 2 7 times. So rather write 2 times 7. And that's how we do the group mean. The answer we get, then we divide by 50, not by 7 because 0 to 6, 7, no, by the total frequency 50. So that's what we did here. 0 times 10, 19 times 1, 2 appears 7 times, so 2 times 7, 3 times 7, 4 times 2, 5 times 1, 6 times 4. When we multiply everything and we add all together, we get 91. And the total frequency is 50. So we get 91 over 50. And that will be our final solution. Now, to determine the sum of squares, we know the mean now. We subtract the mean from each value. After we subtract the mean from each value, the answer we get, we square it, and we get new answer. But don't forget, in order to combine the number, we want to add all the values. 0 and 10 means 0 plus 0 10 times. So the answer we get, we multiply by 10. 1 to 90 means 1 plus 1, 19 times. But we did only 1, 19. So we have to multiply by 19. Multiply by 7, 7, 2. So if you had all these values in the bracket, we should get 50. Then the solution we get, we divide by 50 minus 1. This is a sample size. So we divide by 50 minus 1. And that will give us standard deviation. So again, in these lectures, we go through the measure of a variation. That's how to use the range, the variance, and standard deviation to find the variations of data. Variations of a data is that we want to find how the values in the data set are spread out. If they are spread out very large, the standard deviation, variance, and the range value will be higher, will be bigger. If the values are very close, it will be lesser. Now, if all the values are the same, let's say we have 10 values, or all the values are the same in the data set, then the variance, standard deviation, range, all the values will be 0. So again, I'm going to end here, and thank you for your time, and wish you the best. If you have any question, feel free to contact me. Thank you.